Now there's just one more method I think you ought to see before I finish this video, and this is the method of partial fractions. Okay, so in general, this method allows you to integrate the integral of the ratio of two polynomial functions. So if you've got the integral of f of x divided by g of x dx, where f of x, g of x are polynomials, then this partial fractions technique I'm going to show you gives you a way of integrating a function like this. Now we are only going to look at the simplest cases, just so you get the general idea. Okay, so here's a very simple example. Suppose I want to integrate, I'll do a definite integral, the integral from 2 to 4, 1 over 1 minus x squared dx. Okay. So the trick of this partial fractions is, you see here we've got a polynomial. What you do is you factorize the polynomial. So this is the integral from 2 to 4 of 1 over 1 minus x times 1 plus x dx. And the trick is, if you've got a fraction like this, it's always possible to write it. So 1 over 1 minus x, 1 plus x is equal to something over x minus 1 plus something over x plus 1. It's always possible to do that. Okay. So we have to find out what is a and b. So these things are constants, which will make this formula work. So you can write this as minus a times x plus 1 minus b times x minus 1 all over 1 minus x times 1 plus x. Right. This cancels and I get that for there, and then here these cancel the minus as well and I get that. Okay, so therefore we need to, okay, one more step, sorry. So this is equal to minus a plus b times x, and then I get plus b minus a over 1 minus x times 1 plus x. So therefore we need that a plus b should be 0, because I don't have any x's up here. So this needs to be 0, and b minus a needs to be equal to 1. So you have some simultaneous equations for a and b to solve, which are not difficult. So the solution here is that b is a half and a is minus a half. Okay, so in other words, what we've shown is that 1 over 1 minus x times 1 plus x is equal to minus a half 1 over x minus 1 plus a half 1 over x plus 1. Okay, so therefore we can put that into the integral. The integral from 2 to 4, 1 over 1 minus x squared dx is equal to, so I'll take a half outside, and we get the integral from 2 to 4 of minus 1 over x minus 1 plus 1 over x plus 1 dx from here. Right? And now you can integrate these, because these are just go to logs, right? So this is a half minus log x minus 1 plus log x plus 1 between 2 and 4. Again, you have to be careful to make sure that these functions don't go to infinity between x equals 2 and x equals 4. In this case, you're okay, because these are always positive for this range of x. So when x equals 4, this gives you minus log of 3 plus log of 5. And when x equals 2, this gives you plus log of 1 minus log of 3. In other words, this is a half. So log of 1 is 0, right? So you get log 5 minus 2 log 3. And I like to write this in terms of a single log, so you can use the fact that 2 log 3 is equal to log 9, and log something minus log of something else is equal to the log of a over b. So putting these two things together, this gives you a log of 5 over 9. Okay, so that shows you how the partial fractions method works. So I'll just do one more example just to make sure you get the trick. So the main step is here. You can factorize the polynomial and then write it in terms of its factors like this. Okay. So I'll just do one more example. Integral dx over 2x squared plus 5x minus 3. Okay. So the first thing to do is to factorize. So I've chosen it so it does factorize simply. So 2x and 3. So you need two numbers multiplied to give you minus 3. And the thing here has to be 5. So that's going to be plus 3 minus 1. Okay. So again, we want to be able to write 1 over 2x minus 1 times x plus 3 should be equal to something over 2x minus 1 plus something over x plus 3, which we can write as this. So minus 1. And then putting together the x terms, this gives you a plus 2b times x plus 3a minus b over 2x minus 1 x plus 3. Okay, so comparing this and this, you see that therefore you need 3a minus b should be equal to 1, because the constant term here is 1, and then the x term is 0, so a plus 2b should be equal to 0. And can we get a solution to that? So the easiest way is if I call this one equation 1, this one equation, call this one equation 1 and this one equation 2, then I can do equation 2 plus twice equation 1. So equation 2 plus 2 times equation 1 tells me that, so the b's then cancel the way I've arranged it, so I get a plus 7a equals 2. Sorry, a plus 6a equals 2, so in other words 7a equals 2. So that means a is 2 over 7, and then from here I get that b is therefore minus 1 over 7. Let's just check. So that's 6/7 plus the 7th is 1. This is 2/7 minus 2/7 is 0. Good. Right, so that works. So therefore, you can say that the integral dx over 2x minus 1 x plus 3 is equal to the integral of 2 over 7 times 1 over 2x minus 1 minus 1 over 7 times 1 over x plus 3 dx, and again these are just logs, so this gives you 2 over 7 times a half log 2x minus 1, and this gives you minus 1 over 7 times the log x plus 3. So this is 1 over 7 times the log of 2x minus 1 over x plus 3 plus c. Okay, so again, you need to be careful about when these functions blow up, but in general that will be the answer. Okay, so I think these are all the different integration techniques you need to know about, so hopefully that will be enough to help you with today's with this week's practice sheet and with the test as well.